All right. How's everybody doing today? I hope you're having a wonderful day. Welcome back into the stream. My name is Michael. I'm 26 years old. I got a degree in human biology and a minor in chemistry. And I work as a formulation chemist for a biotech company, and I've been teaching myself how to code for a little over a year now. We are going to be jumping today back into MIT OpenCourseware. We've been taking the Introduction to Computational Thinking and Data Science course, the second half, the 6.0002, the second half of this term. As the first half is more basics, and we've kind of already surpassed all those. So we are into problem set 2 today. So we've gone up to lecture 6 and I've completed problem set 1, and today we are going to be in problem set 2. All right, we got the Twitch started here. Nice. Let's go ahead and get this loaded up. It's been a while. I got to remember how to do all this. Copy. Social stream. Okay. Nice. I think we're good to go. Cool. All right, we got chat good. All right, you guys, let's go ahead and get started today with problem set 2. I'm hoping to complete this at about maybe under 2 hours. Hour and a half is my goal, and hopefully we don't have to go and do a day 2 tomorrow. All right, so let's get into this here. Let me turn off that. Okay, problem set 2, fastest way around to get around MIT. Right? All right, in this problem set, you will solve a simple optimization problem on a graph. Specifically, you'll find the shortest route from one building to another on the MIT campus, given that you wish to constrain the amount of time you spend walking outdoors in the cold. Okay? Download the files ps2.py, the code skeleton, and graph.py, a set of graph-related data structures, digraph, node, and edge that you must use. MIT map.txt, a sample data file that holds the information about an MIT campus map. Okay, so we have ps2.py, which is our, we're going to write code. We've got the graph.py, which holds our classes for setting up a graph. And then we have MIT map, which is a text file of data points. Okay. Sample data, the information on the MIT campus map. Here's the map of the MIT campus that we all know and love. From the text file, mitmap.txt, you will build a representation of this map in Python using the related...
Dracu says hi.
Hey dude, how's it going? Draco. Using the graph-related data structures that we provide. Each line in mitmap.txt has 4 pieces of data in it in the following order, separated by a single space. Right. Space delimited. The start building, the destination building, the distance in meters between the two buildings, and the distance. So the start building, the destination building, the distance in meters between the two buildings, and the distance in meters are between the distance in meters between the two buildings that must be spent outdoors. For example, you suppose the map text file contains the
Dracu
following
says,
line.
what are you doing?
We're doing an MIT OpenCourseware problem set 2 here for 6.0002. This means that the map contains an edge from building 10, start location, to building 32, and that is 200 meters long, where 40 of those 200 meters are spent outside. During the day, Routes are crowded and only allow for you to travel in one direction. Problem 1. Creating the data structure representation. In this problem set, we are dealing with edges that have different weights. In the figure below, the blue number shows the cost of traversing an edge in terms of total distance traveled, while the green number shows the cost of traversing an edge in terms of distance spent outdoors. Note that the distance spent outdoors for a single edge is always less than or equal to the total distance it takes to traverse that edge. Now, the cost of going from quote A to quote B to quote E is a total distance traveled of 22 meters, where you have 15 plus 7 for 22 meters total, but only 14 of those 22 meters are spent outdoors. In graph.py, you'll find the node and edge classes which do not store information about weights associated with each edge. You'll also find skeletons on the weighted edge and digraph classes, which we use in the rest of this problem set. Complete the weighted edge and digraph classes such that, okay, so here's our problem. So in graph.py, you'll find the node and edge classes, which do not store information about weights. Let's go look at that. Right? So graph.py, we have a node class and an edge class. Okay, so our node class just has a name. You can get the name, you can stir represent it, equals, not equals, and you can hash it. This function is necessary so that nodes can be used, keys in dictionaries, even though nodes are immutable. Okay, you just hash the node, and then that's what you use as the key of the dictionary if you need to store it. Okay. Now the edge class has a source and a destination, and that's it. And you can get the source and destination, and you can get a stir. Pretty easy. Okay. You'll find the node and edge classes which do not store information about weights associated with each edge. You will also find skeletons of the weighted edge and digraph classes, which we'll use in the rest of this problem set. Okay, so our task today, or right now, is complete the weighted edge and digraph classes such that the unit tests at the bottom of graph.py pass. Okay, so we need to complete the weighted edge and we need to complete the digraph classes. Okay. Such that the unit test at the bottom of graph.py pass. Your weighted edge class will need to implement the stir method, which is called when we use the stir on the weighted edge object as follows. Suppose we have a weighted edge object E containing the following information: source node name quote A, destination node name B, total distance along the edge 15, outdoor distance along the edge 10, then stir E with the above information should yield A arrow B 15 10. Okay, this is pretty easy. For digraph, you will need to implement the add node and add edge methods. All right. This doesn't seem that difficult, but I usually say that and then I end up working on it for 2.5, 3 hours. So let's see what we can do here. I'm gonna go ahead and load up some tunes. Hey Austin, how's it going, dude? Hey Michael, I like that name. How's it going, man? How you guys been doing? Sorry I didn't stream the last couple days. I was busy 2 days ago doing shopping after work for my girlfriend's birthday, getting gifts last minute because I have to get gifts last minute because I am a spoiler. I will give it away. So I have to go last minute. That's just my excuse, I guess, to procrastinate. But I have to go last minute because I get too excited about gift giving. And then then yesterday was her actual birthday, so we spent all day, doing stuff for her and hanging out and going shopping, and it was a good day. So I appreciate you guys, being patient with me on those. But we're back here today, so let's go ahead and get some music going, and we'll keep it chill here. All right, let's solve this MIT problem. Okay, so we need to solve these classes basically to get the unit test at the bottom here to pass. Okay. Okay, let's go ahead and get into this. This is fun. All right, this is really easy. So self.source is equal to source. Let me just copy this down and do destination, total distance, and outdoor distance. Right? So get total distance will return self dot total distance. Get outdoor distance will return self dot outdoor distance. And under stir, we have to represent it in this format here. So we're going to return. I'm going to do an F string here because I like F strings better than dot format. So we're going to use F string, and I'm going to insert here self dot source, right? Arrow self dot destination, and then we just do parenthesis self dot where total distance is first dot total distance, and then we'll do self dot outdoor distance, just like that. All right, done. Weighted edge done. That was super easy. No way, dude. There's got to be a catch. This can't be. This can't be a. Why is this so easy? What's going on? What's going on? Cool. Pretty simple. Okay, so now we're moving on to the digraph. So for digraph, you'll need to implement the add node and add edge methods. So our nodes are a set of nodes and edges are a dictionary. Must be a dictionary of a node with a list of edges. Okay. So we need to do this. Add a node object to the graph. Raise the value error if it's already in the graph. So I'm trying to figure out kind of like what they're wanting here. So adds a node object to the digraph, which is this. Okay. But where do we need to add it into the node set, right? Now, do we also have to add it into the edge as a blank? Yeah, I think so. Okay, let's go. Let's do this. So for this one, it's pretty easy too. So we'll say if now is this node, so if node in self.nodes, I don't need to overcomplicate, let's just try this. So if node in self.nodes, we're gonna raise this value error that'll say is already in the graph. Add node error. What I'll do is say F string node already in now I could put self dot stir here, right? So we know that nodes also have a stir representation. All right. I'll fix their type hinting, don't mind me. Don't mind me. I'll take care of it. MIT. I'll take care of it. For or in type pending, is it? Is it that? I guess I'm not that good at type pending. Okay. So that add node, so if the node is in self.nodes, we'll raise the value error, right? Now, if it's not in self.nodes, we can add it in. So we'll go ahead and say self.nodes.add node, right? So now add edge. So do we also need to, now let's do this though. Let's go self.node, edges. We're going to index into here and call node.hash. And then we're gonna say is equal to an empty list. I think that's what they're wanting here because they say in this node, this function is necessary so that nodes can be used as keys in a dictionary, even though nodes are mutable themselves, right? So I think we need to hash the node on add into the dictionary, but just set its edges as blank. Because we're not indicating a source, right, to attach this node as a destination. We're just adding an arbitrary node into the object. So now that we have that, I wouldn't have to return anything. So I think we move on. Now if we need to add an edge. So adds an edge or a weighted edge instance to the digraph. Raises the value of either of the nodes associated with the edges not in the graph. Okay, so oh crap. So let's go back up and look at these edges. So an edge has a source and a destination, which are nodes. Okay. Right. And then the weighted edge has a node destination, a node source, and then applies some values to the edge rather than just linking the two together. Got you. Easy. Easy, easy. Oh, sorry, outdoor distance. What is this? Float? Float? It might be an integer. Do they ever use float integers? Let's see. For floats? No, they're always whole integers. So let's just use integers. Okay, so that's cool. So then to add an edge, right, we're going to say if edge dot source or edge dot destination so if this not in self dot nodes or edge dot destination not in self dot nodes, right, we're going to raise this value error because we don't have our nodes associated with an edge here. You need to associate some nodes with an edge first and create it, and then add the edge to the object. So raise, we'll say add edge error. It will say edge equal to edge dot stir, right? Has no source or destination nodes, right? Okay, so then if we have nodes as an edge or a weighted edge, so edges are unidirectional. So we only have to apply into the edge for one node. We don't have to apply for the inverse node. Cool. So what we'll say here is source node hash is equal to edge dot source dot a hash do you have to call this like a function? Do you have to call it like a function? Let me look that up. Self dot stir call versus self dot under stir with a function call. Okay, so you do call it. It's not like a property. Right, okay. So let's attach some functions to these. I think we attach a function here as well. Potentially, I don't know. Am I wrong? Hey James, dude, how long have you been learning Python and programming, and what resources have you used up to this point? Trying to start learning Python to hopefully build some beginner projects, but don't know where to start. Yeah, dude, that's an awesome question. Appreciate you coming in here, James. I have the perfect answer for you. I have a Discord for free, link down in my description of my YouTube, where it has a compilation of my entire roadmap for every book I've read, notes I've taken, projects I've worked on, community projects from the Discord people, and YouTube channel and Twitch. So it's a really awesome resource to get in. I also share some stock stuff. Yeah, so I highly suggest you take that out and join us in the Discord. Community projects, like, you know, work along projects, like all that kind of stuff. So yeah, it's a great thing. So we'll say if source node hash not in self dot edges, right? We're going to raise another value error that will instead say this time around edge edge hash edge not found in edges predict. Something like that. I mean, I don't think we'll ever hit this because in our add node we are doing this, right? So let's do this. So we'll go like this. We'll say node hash is equal to this node dot hash, and then I'll say if the node hash not in self dot edges, or if it's already in. So we'll raise another value error. I'm probably overkilling this like hella, but I'm trying to get an A here in MIT. We're going for the A in MIT. And then we'll just put node hash here, right? Rather than calling that again. We have it saved. Right. Cool beans. Add edge, self.node, raise error. Okay, got you. So now that we add the edge in, but we check to make sure it's first not in the edges already. So, not terrible. Now if we add edge, right, if it's in, we raise this value error, but so now we need to add it. If edge, so we've already checked, so we'll just say source node hash, we'll say is the key of self.edges, right? And then we're going to say dot append we know it's in there now, so we'll say dot append we want to append to the list the edge. Okay, let's try this out. Failed. Crap, dude. Crap. Uh-oh. I'm getting hit with these value errors. Okay. Crap. That sucks. I was hoping we would get through this one. Let's see where we went wrong with our calls here. So our first errored out on add test edge, right? Hold on. What's going on? I'm gonna take off it's getting hot. It's getting hot, y'all. Hey, we got 24, 25 people in here, y'all. Leave a like. Leave a like. I appreciate you guys being here. My name's Michael. I appreciate you guys joining. I got a degree in human bio and minor in chemistry. We're taking the MIT 6.0002 course, the second semester here, Introduction to Computational Thinking and Data Science. We're on lecture 6 and problem set 2. Getting into Monte Carlo simulations and all that jazz. So kind of more diving deeper into computer science and programming with, models and deeper algorithms and stuff, or at least trying to break past kind of the more entry level or kind of basics of Python, really. So, all right, so where are we going wrong here? Let's figure this out. Okay, error test non-existing graphics expect call. add edge self.e1. Here I get my first error. Edge.demonstrator has no location. Edge equals has no source or destination location. So we wrote that in. So what's the deal here? I'm sorry, I don't know what's going on. This is a weighted outdoor distance. Test Grafster. Okay, something's going on with our errors. So in our add edge and add node here, so we're saying we're getting hit with this guy. Destination nodes. If the edge.source not in self.nodes, or if edge.destination okay, let's do this. If edge.source, right, and then let's copy this down and say edge.destination not in self.nodes. Raise a value error, saying edge. We'll say, I think I have to say, or maybe it isn't a function call here, has no source or destination nodes. Has no source. Node, and then has no destination node. Right, so now we can get this explicitly, rather. Let's try that. Oh, because it's calling stir. Is that not working? Let's just do this. Stop trying to be fancy here. Distance. So you with edges and source node. So if edge.source, so what is the edge? The weighted edge has a source here, which is a node, right? And destination. The source represents an edge with a source and a destination. which are nodes. This is just the Luna Lounge on YouTube. I think he's an AI artist. Okay, so we're getting failures here still. I'm really confused. Let's print out node here, right? I mean, I don't know really what's going on. So I keep hitting this value edge has no source node in the add edge. Got hit with that. Edge has no source node in add edge. Edge has no source node. Edge has no source node. So it's not getting anywhere here. Okay, let's just let me go up. Get out of here. Okay, here we go. So errors. Test node, we're at the top here. Add edge error. Edge has no source node. We hit that for every single call. So in my add edge, I have if the edge.source is not in self.nodes, which is a set of lists, it's a set. So when I add a node, oh, huh. No, I do put it into add node into that. Did I not do this? Did I delete it on accident somewhere? Okay. I think I deleted it somewhere on accident. My add node. I was never even adding it in the add node method. I think I deleted it when I did this hash update thing. Alright, what a goofball. Come on, Mike. You're screwing yourself. Alright, then this error is easy because I think I saw what was going on. We just need to go like this. We just need to go to our we need to go to our stir method here and just give a space right here. Alright, we passed. Come on, dude! That's so annoying. I swear I had that line of code in there. That is just one line. I had the add node in there. I just was never adding it. I think I accidentally deleted it when I was moving these lines around. I have to go back in the video, in the VOD and watch. I swear I added the node already. That's so troll, man. Alright, we passed in the... Alright, problem 1 done. Whoa! Let's go. At what level would you say I need to start contributing to community projects? Honestly, they're really simple and pretty easy in my opinion. Let me just give you a quick, we'll move on to problem 2 right now, but let me give you a quick, I'll just give you a quick flash of like what we're doing. So a current community project right now I have open is Stalker. It's basically like a portfolio visualizer where you can add account as objects, add accounts, and accounts are like financial accounts, like a Roth IRA, a 401k, a individual taxable investment account, a whatever. And you can add the account, and within the accounts you can load and add positions, right, to display. And as you would have positions in my Roth IRA, I have Apple, Nvidia, and whatever. In my 401k, I have blah 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 blah. In my individual taxable, I have Palantir, blah 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 blah. So, and then what you can do is put them all together into a net worth view with Tkinter. Boom. So I haven't built the portfolio page yet, but we built the accounts page, which is the bigger page. So right now you have like this view right now. So you have all of your accounts, you have a total value of a little over $5,500 with unrealized gain of $5,500 because of this simulation. I gave 0 average cost to all of so I pretty much got all these shares for free. So now I can also specify a view update to just the individual accounts themselves. So these are the positions in the individual taxable, and then these are the positions in the Roth IRA. And then you can add a position within that account. And so it's a very simple script using, it's pretty, if you know some Tkinter, it's pretty easy to get up to date and speed on. But honestly, just adding like little methods and stuff, it's pretty basic using object-oriented programming. I've really tried to set it up in kind of a beginner-friendly manner. So just try to take a peek through the code base on my GitHub and see what you got. I also have another project I'm working on right now that you can also feel to contribute to. I really don't mind, but it's better options. It is a personal project right now, but on the same lines of financial education and stuff. That's kind of fun. I'm writing this script to kind of evaluate, I think would be fun, to evaluate the validity or kind of strength of an option contract. So if you're unfamiliar with what options are in finance, then good for you because you're not a degen and you're not going to lose all your money. But sometimes options can really make you a lot of money too if you're right, which is not very often. But so I have this kind of thing where I'm kind of pulling information. Right? I'm pulling information. As you can see here, I pulled, according to my limit of 5, I pulled the 5 from both in and out of the money contracts, which basically means like if it's in the money, it's below the current price of the stock, meaning it's already been, the value's been captured and it's growing, versus out of the money means you're betting on a future move out of the money. Like it's like, it's not as simple as just betting on the price movement to a certain price, because you have a time factor decay, you have like a volatility factor decay, you got a lot of crazy other types of variables that play into these contracts to give them a lot of different movement indications. Like these Greek values associated with option contracts are what kind of give the contract its behavior, like how much it decreases day by day, how much it increases per dollar the share actually increases, right? So like the intrinsic value of the contract itself, because you can exercise the contract and obtain the 100 shares, or you could sell the contract early, kind of like hot potato, and just take the intrinsic value, I think, or actually I can't remember, and just walk away without the shares. So what I'm doing here is I'm computing the Black-Scholes model using some object-oriented power programming I wrote and Y Finance. So I built Y Finance to create I use Y Finance to build a stock that has some data associated with it, and then I get the options chain of that stock and optionally save it to a file. So you can see here's the options chain for Apple currently at the close. And then what I'm doing is computing the Black-Scholes model across each of the options, and then computing out values that way. So what you're seeing here is the Apple currently is at 218. So the 220, the 215 is the in the money contract, and the 220 is the these are the at the money contracts, right? They're kind of in between because they go by $5 increments. So the kind of at the money is kind of around this 220 mark. And as you can see, the Black-Scholes model is giving these current values are a little bit, the Black-Scholes is actually showing that these might be a little bit undervalued, or like a little bit on a discount. Now, you don't want to just take these at face value and go ahead and invest off of the Black-Scholes model. You would want to find other indicators to give you an edge, right? You would want to use, maybe a change in volatility over the course of the past 3 days to see if price is really, or interest is really moving up. Maybe institutions have been buying, heavily over the past, maybe week or 2 weeks. You would maybe use information about volume, how much volume on that day is being attracted into the stock or over the past couple of weeks, because implied volatility is the anticipated move versus actualized volatility, which you can compare against, right? You can compute the implied volatility, which is what people think the stock is going to do in the future, what percentage it might move, versus or what the stock might, the contract might become versus what it actually did become. And you can see, the trend, is it undervalued or overvalued? Or are people, paying more, or are they paying less for this and compared to where it should be, where people thinking it can go? And so you can compare these models together, in my opinion, hopefully, somehow, if I keep adding different little indicators and adding little features and puzzle pieces, such as the Black-Scholes model, maybe an IV screener, maybe a volume scanner, maybe maybe I can use all these different tools to give an overall rating to a contract and give myself a little bit of an edge. So I think it could be fun to just go down that road, and I don't think it'd be very hard to implement. The hardest part is just kind of figuring out, the models themselves and understanding what they're doing. But finding them using AI and the internet nowadays is really easy. You can really just look up, kind of give me 10 financial models that people use in their edges, and you can get a good couple of models to use. Now, obviously, you probably want to do some deeper digging. Oh my gosh. Deeper digging. Yeah, deeper. Jeez, I cannot talk. To find some more information, right? But it's kind of a cool idea. But I'm going way off topic. That's one of my personal projects. Same with the stalker, that you can kind of contribute to and give ideas that I'm working on right now live on the stream. But in between this course, of course. But let's get back to business here on the course. Sorry for that slight detour. Let's go ahead and keep going. So we're taking the MIT 6.0002, the second semester of the Introduction to Computational Thinking and Data Science course, to kind of dive deeper into more intermediate, and then eventually into math and advanced, computation, whatever. So, yeah, it's pretty fun, and so far, and we watched up to lecture 6 so far on the channel. I have those been streamed live as we watch them, kind of like a reaction, and I took notes along the whole thing, so you can, if you struggle with, taking notes and paying attention and focusing and extracting out what the professor is saying, use my my watch along as your watch, right? Like, I'm streaming the lecture and I'm recording it and re-uploading it as well, so you have 2 places you can find it, the live or the kind of more condensed re-uploaded. So, and if you struggle to kind of focus, pay attention, extract out the information, take notes, use me as like an example, and let's watch it together. So I think it's really fun, and I really don't think a lot of people have done this on YouTube yet. So I think it's kind of a cool new niche that I'm kind of been like creating, almost like kind of watching lectures. Like, people do reaction stuff, but I honestly, there's probably I haven't seen hardly anything about like people like reacting to educational and like live learning and stuff like that. So, and it's kind of been proven successful so far. We're up to almost 3K subs here, so sub along. I stream every single day around 7 p.m. PST after my 9-to-5 job as a formulation chemist, where I work at a biotech company since I graduated back in 2021. I primarily specialize in kind of large-scale advanced chemical formulation, mathematical matrix manipulation for like producing theoretical yields, and then actually going and producing those on a large scale, up to like, from 500 to up to like 4,000 liters of solution for biological controls. So blood, plasma, urine, all these kinds of things. So I appreciate you guys being here and hanging out with me as I learn and teach myself computer science. We are going to jump back into part 2 of this problem right now. So we just finished problem 1 of the problem set 2. And so we're going to move on to problem 2 here. So problem 1 here was just setting up these classes for them and then getting our test to pass here. So we got that as a pass. So okay, problem 2, building up the campus map. For this problem, you'll be implementing the load map function, which takes in a map file name in the problem set2.py, which reads in data from a file and builds a directed graph to properly represent the MIT campus map according to the data. Which reads in data from a file and builds a directed graph to represent. Okay. Design your graph. Decide on how the campus map problem can be modeled as a graph. Write a description of your design as approach as a comment under problem number 2 heading in the ps2.py. What do the graph nodes represent in the problem? What do the graph edges represent in the problem? Okay, so it wants us to give like some type hints. Or not type hints, some doc strings here. Okay, so let's go into ps2.py here. And it says here. Oh, here we go. Okay. So what do they represent? Okay, so graph nodes represent locations, building locations on MIT campus, right? Are they building locations? I think they're just buildings, right? Right. A node is just a name. I think it's just a building. Buildings. So it's not locations, it's just buildings on MIT campus. A node contains a name instance variable. A node or building, MIT campus building, contains a instance variable, a quote name instance variable. Right, that's a string. What do the graph edges represent? Graph edges represent connections from one MIT campus building to another. Graph edges represent connections from one MIT campus to building to another. These connections are unidirectional and unidirectional with a source node and destination node. Yeah. From a source node to a destination node. Cool. Let's keep going. Where are the distances represented? Edge distances are represented within the weighted edge child class of edge, right? No. Oh yeah, wait, it does take an edge. So why do you take in edge, but you don't inherit any of edge? You get the methods here, but why not just inherit the source and destination directly from edge? I guess they're trying to say that, so you can't use an edge actually to create a weighted edge. You have to create a weighted edge from scratch, because you're not supering the initialization of the source and destination from the edge parent. Sorry, let me catch up on chat, yo. Sorry. The stream is pretty cool. Thanks, dude. Polly. Hey, Polly Gaming. It keeps my focus on current code stuff. Keep up the work, dude. Nice. Yeah, that's the whole goal, is if you are struggling, focusing on just really anything, you can just pop on the stream in the background and have it play and, work on whatever project you're working on. You don't have to be directly focusing on what I'm doing, but just having it in the background and hearing the kind of subject matter as kind of subconsciously really can reinforce things. There's been proven science about that. And it'll just kind of help you keep you focused also while doing your own work too. Gotta break my alert and head out. Later, Austin. Have a good night, dude. I love having you come in, man. You're awesome. Fortnite official. Build it back. I haven't played Fortnite in like 5 to 6 years. Hello, Biochemist. Well, in my career, I've been more of an analytical chemist, but my degree focuses with biochem. Oh, nice, dude. Yeah, dude, I guess I'm like biochemist in terms of I have a degree in biology, but I'm a professional chemist. So that's why I kind of say biochemist. I don't have a degree in biochemistry, even though I did take biochemistry courses. I have a degree in human biology and a minor in chemistry, so kind of a little bit of nuance. But I say biochemist, kind of merge the two fields together, I guess. But I guess my profession is more of analytical chemistry. I do data analysis and computation across multiple configurations and manufacturers for immunoassay analyzers and stuff like that, for very niche analytes on a biological level. I'm 26. 26. Woo. 47 load. Getting old, man. I'm getting old, dude. Learning C# right now. Not super easy, but having fun. Are you a Windows guy, Mr. Beast? You a Windows guy? Polly says, that's pretty neat. I'm actually working on some wearable med tech right now. Wearable med tech? Jeez, that's pretty cool. Yeah, course link. Yeah, for sure. Honestly, it's just MIT open courseware, but I'll try to here. Let me throw it in chat here for you. Oh crap. Oh, I don't have the ability to chat here. Let me pull up chat on my docs. All right, there's the course link for you. Hey, Tristan. Meow. Did I miss the basics? No, I go back through on my channel and I upload. I highly suggest you guys take Harvard CS50P as well as pairing that with Python Crash Course. That's kind of been my like bread and butter and what I've been telling people on my channel, and that's what I did. Is yes, Harvard CS50P was a little bit difficult, from someone with no programming experience at all coming into it. Understanding these different things, and it's a whole new thing. It's learning a whole new language and idea of thinking. But pairing that with Python Crash Course to help kind of break those subjects onto a more elementary level. Yeah, the Python Crash Course like really kind of aims to be more like kind of like kiddie and childish, but in my opinion, that really helps to just remove all of that kind of abstracted fuzz of of everything else by just breaking it down to its core concepts of just variables, lists, looping, classes. But just using just simple elementary examples: pizza, dog, cat, cow. Like it's very simple like that. But it's what really helped to kind of just forget all that BS and kind of just focus on the code itself. But I am going back through that book and uploading the Try It Yourself crash course problems. So go check out the videos on my channel. They're only like 2 or 3 minutes long. They're just like the solution videos to the in-text problems. Try it yourself. I'm going back through for you guys. What is the document on the right of the screen? Oh, that's just the PDF of the problem. So I downloaded from the website MIT OpenCourseWare the problem set 2 here, and this is just the PDF of the basically the homework assignment. Okay, so I keep getting distracted here. So here we go. Edge distances are represented within the weighted edge child class. Weighted edge child class of edge. MIT did not inherit the source or destination init vars from parent edge, right? So source and destination are needed on instance, are needed on input, which kind of sucks. I don't know why they did that. Cannot directly subclass edge to weighted edge because I'm going to talk to the GPT about that. I want to have a conversation about that. So a way also I've been kind of teaching myself and learning is that I do use AI to learn and teach myself, but I do preface, and you guys will see me use AI live. I do everything transparent for you guys. I try to be as honest as possible. Is that I just tell it, I'm confused about this, but I really try to have a conversation rather than just get an answer. So I say, I'm confused about this. This is what I'm thinking. This is why I'm confused. Can you point me in the right direction? And go from there. Or, think of, interacting with your TA. If you ever had a TA or a professor's assistant or a UTF or whatever it is in college for you, they would never give you the answer outright. They would coach you and guide you there. And then if you're really struggling, then eventually probably give you an answer to learn from, right? So, treat it that same way and be responsible and accountable in that front. And I really think you can grow quite fast because I've been able to teach myself, all these aspects of programming so far in just a short year on the channel. We've read books like Data Structures and Algorithms in Python, about 3/4 of that book, about a quarter of Fluent Python. We've read Python Crash Course. We've read not hardly anything of machine learning in Python, but we're getting into machine learning here because at the end of this course, it actually kind of fades into machine learning and starts to kind of transition into it. And so my goal is to finish this course and then to kick up 100 days of ML. Woo! So I want to get into ML and start doing that and start, running maybe some chemical simulations, machine learning simulations across, different because I built projects like SpectroSim, so you guys can go to my website. I'm rambling on here, sorry you guys, but my website michaeldeming.com, and you can access my projects and stuff. SpectroSim, which is a really awesome site I built, full stack site I built live on stream here, which taps into PubChem database. It's currently used as render.com to host as the backend, so it's pretty slow on the initial startup. So this initial search does take about a minute. It really sucks, unfortunately, from the free version of render.com as my hoster. But once you get past that initial spin up, the searches are pretty much instant. So it taps into PubChem database and automatically generates and parses out a spectroscopy and generates a spectroscopy for the absorption of that compound. So you do these types of experiments in your undergrad as a chemistry, either major or biology, or if you're in chemistry. And so I'll let that load here so I can show you guys what it looks like. Has anyone suggested using Jupyter notebooks? Yeah, people have suggested that. I've kind of messed around with it a little bit. I honestly don't really understand it. I haven't given it the time I need to actually learn it. I've just been using Markdown as my notes. Like here, I'll show you like lecture 6. This is my notes. It's honestly really pretty. Like it's really pretty. It gives like the basic Spark notes, and this is all on my GitHub for you guys as well. So if you guys are wanting kind of like the Spark notes through the course and what I did, I took live on my streams, you can access that on my GitHub and everything. So all of my notes for my lectures, all of my projects, everything I'm doing on this channel is completely documented. So yeah, it's kind of cool that way. Okay, we got to stop getting distracted. We got to keep going here. The stream's going to never end. Okay. Right, so distances are represented in the weighted object. The edge just has a source and destination, whereas the weighted edge has distances associated with it. Okay. So, all right, let's go ahead and get into the next problem here. Where are the... Oh, I think this is mainly wanting for like, where are the distances represented? They're in the... Oh, it's fine. It's whatever. Okay, problem 2b. Implementing load map. Okay, so implementing load map. According to the specifications provided in the doc string, you may find the following link useful if you need help with the reading files. We don't need that. Problem 2c. Testing load map. Oh. Okay, so we just got to do this. Okay, so load map with a file name. Parses the map file and constructs a directed graph. Map file assumes each entry of the map consists of the following 4 positive integers separated by a blank space. All right, cool. All right, let's get into this. So we need to, we're going to open the map file name, right? We're going to open this in read mode, and we're going to set new lines for like Windows users as blank strings. We're going to pass over them, or whatever that means. So then we're going to say as file. Right. So now we have the file open. What we're going to do, actually what I'm going to try, I'm going to go like this, try, right? We can use a try except here. I usually always forget to do this initially. Let's do a try except for a file not found error. And then we're going to say print load map error file not, we'll say file equal to, and we'll put an F string here that says map file name not found. Cool. So what do we need to do to this file? We need to parse it for one, and we need to go row by row and get the data from here. All right, that's fine. So if we say file.read lines, that'll return the lines to us. And if we say for line in lines, we're gonna do line.strip to strip off all the delimiter characters that come with read lines. So read lines will give you all the \n, tab, r, all that jazz. So strip will get rid of all that off the ends. Yeah. So then what we're gonna do is say I could parse over every char, but I don't think I want to do that. I don't want to have to go over every line and then every char and every line. I could just use the split method. Right on the space character. So maximum number of splits needed. The default limit means no limit. Okay, so we'll split this and we'll save the values as an unpacked. What are they? I'm sorry. What are they? What are these? Okay. Start. Okay. So source, destination, total distance, and outdoor distance. Right? So if I say so now what we're going to do is go like this. New node is equal to node, and we're going to say name equal to source. New node destination, right, is equal to a node name destination, and then we're going to say weighted edge, new edge is equal to a connection between source equals to new node source, destination equals to new node destination, and then we have total distance equals to int of TD, and then outdoor distance equals to int of OD, right? So we're going to create these nodes, create this weighted edge, and then what I'm going to do is go like this. Blank or new map is equal to a diagraph, right? Okay, and then we're going to say new map dot add node for new node source. We're going to copy that down, say new node destination. We're going to go new map dot add edge, and we're going to add in the new edge, right? Cool. So we open the file, we read the lines. The lines look like this, right? So we're going to get a list of all these lines, which are just strings. We strip off the ending characters, right? And the beginning characters. We split across the space between each of these, indicator values. We save those in these 4 variables. We then assign a new node creation to the source name of that node, a new node creation with the destination as the name of that node. We create a new weighted edge where the source is the new node, the destination is the destination node, and the distance total is the TD, and the distance outdoor is the OD. Then we add those 2 nodes to the map, and we add the edge to the map. And then we move on to the next line. Okay. Test whether your implementation of load map is correct by creating a text file, test loadmap.txt, using the same format as ours. Loading your text file using the load map function, and checking to see if your directed graph has the nodes and edges it should. What? Test whether your load map is correct by creating a text file. Load your text file using the load map function. I'm so confused. Why? Test whether your implementation of load map is correct by creating a text file that's called test loadmap.txt. Using the same format as ours, loading your text file using the load map function and checking to see if your directed graph has the nodes and edges it should. You can add your call to load map directly below where the load map is defined and comment out the line when you're done testing it. Your test case should have at least 3 nodes and 3 edges. For example, if you had nodes A, B, C, and edges, if you were to print your graph, it would look something like this. Oh, okay. So it still wants that loading map from file. Okay, and then it'll print and then we return the new map, right? Got you. Okay, so we just need to create a new file called test load map.py, .txt. Okay. We need to throw in some values. Okay, let's just take the first 4 of this guy. And then we're going to run load map on, so we'll say loaded map equals to load map, and we're going to do it on, okay, test load map.txt, and then we're going to print loaded map. Okay, I got file not found. So let's see here. Let me copy relative path. Node 36 already in 32, 36. Node equals 36 already in. Oh, crap. Add node error. Node equals 36 already in. Oh. So node here. So it's already in there. Self dot nodes. Okay, so add node error 36 already in 32. So if node is already in self.nodes. Okay, so now if let's run this 36 and 32. So I already have the node 36 in here. So why is it trying to add 36 again? Oh. Okay, so the thing is when I do add node, right? I check to see if the node is in self nodes already, and then I check to see if the hash is in, right, the edges, right, to see if as the key. Now and then I add the node. Okay, so then I'm trying to create a destination node. Got you. So I call add node here. Onto probably a so what I should do, should I only add the source nodes? I need to add, should I not add the destination node as well as the source node into here? because what it's doing now is if I'm adding both nodes into the digraph as its node object, right? Which, because I'm having two nodes that are created, should I only add the source? So this goes 32, 36, 36 to 32. 32 goes to 57. So I've already done the 32. So, but it wanted me to raise a value error if I tried to add a node that was already in. That was part of the instructions. Let me catch up on some chats. My code is so atrocious that it tells me to my face it sucks and changes all my code. Hey bro, I heard you were trying to learn calculus. Yeah, I started to learn do a calculus 1 refresher course, but I haven't done a lot of work on it. I'm gonna be honest. Hey, how's it going? Thanks for coming in. Hey Finn, how's it going, dude? I understand, but I'm just kind of learning more for fun and learning to code to take on new skills. So whatever comes from that, comes from that. Hey Cody, how's it going, dude? Hey Ray. Thanks for coming in here. Sorry, I was focused on the problem here. If I read chat, we never get the problems done. If I keep the problems, I don't read chat. So trying here. So it's interesting. This problem wants me to. I had to. That's annoying. I had to use. Okay, whatever. Let's just do this. I'll just do it. I'll just hack it, I guess, my own little way. I'm not sure if this is allowed, but whatever. I'll just do this. So accept value error. Um, um, so we'll just I guess pass over it. Like we don't really need to. We raise the value error ourselves, and then we'll catch it because we know that it's there that's already in there. Destination node already in graph. And if you add an edge, this just adds a new edge given the source node. Okay, so now let's try it, I guess. Load map error. You're not finding our map. Problem sets. I'll do this. This is so frustrating. Let me do what I said earlier. It's probably way easier. Okay. Oh. Do a stir map. Class map. Print loaded map. That prints. Okay, that's why. So then if I say that is obviously, there we go. Okay, cool. We fixed it. So we caught that these nodes are already in the graph, and we built this graph right here. Hey Cody. This should seem way out of my fun zone, especially for learning to code. Yeah, it can be pretty tricky. Sometimes people come in here and they're kind of know it all sometimes and can kind of put me down sometimes, but it's okay. We keep pushing. We keep pushing. Okay, so now we got that done. Cool. All right, I think I'm going to potentially pause here for today and pick back up tomorrow. I am pretty tired and I have not eaten yet. I got off work at 6 today. I worked through pretty much through my lunch, and so I barely got anything to eat. I worked until 6 because I had to release a product today. I released a product to filling, and then so I had to stay late and get that done, and then it took me like an hour to get home, dude. Over an hour to get home. So I got home at like 7:15. I walked my dog and I started the stream at a little past 8 because I usually start around 7 p.m. PST. So thanks you guys for being here and hanging out with me and for that portion. And for if you guys want to come back, please come back around 7 p.m. PST. But today I was just a little bit late because I got off work so late, and then dude, the traffic was brutal. I got wrecked, and then I had to take my dog out and get her situated. So I didn't get on until later. So we probably could have finished this problem if I would have gotten on at 7, but shoot. I wanted to get it done in one stream, but I'm kind of tired, you guys. I've been going all day. I have a 9 to 5 job as a formulation chemist, and I code and teach myself how to code every single day afterwards. So I run out of gas sometimes, you guys. I appreciate you guys being here. Hey, Praga, how's it going? I'm a beginner. Can you please teach me? Yeah, no worries, dude. I have a Discord link down below in the description where you can get access to a complete roadmap of my learning journey from every book I've read. This stream is a complete documentation of my learning journey, completely transparent. I am showing you guys everything I'm learning and coding live. All my projects that you guys can find on my site, michaeldomain.com, are live on my channel. Oh, I forgot to show you my site, SpectraSim. Here it is. See, you generate aspirin and you get the thing. Dang it! Sorry, you guys. I forgot about it. We built that live on stream. All right, you guys. If you guys are new here, please like and subscribe. I appreciate you guys being here and hanging out with me today for this part one of the fastest way to get around MIT. We are going to do problem 3 tomorrow. So we'll tackle problem 3 tomorrow, which is the actual. We set up everything, loading, building the class structures, and now we're gonna actually write the algorithm for finding the shortest path across these objects. So that will be our goal for tomorrow, is to actually write the shortest algorithm path for the optimized depth search of this kind of tree, or this kind of linked list almost rather. Um, so yeah, I appreciate you guys being here and hanging out with me so far. Like I said, my name is Michael. I have a degree in human biology. I'm 26 years old, and I have a minor in chemistry as well. I work as a formulation chemist, and I teach myself how to code every single day around 7 p.m. PST. So I appreciate you guys hanging out with me and coding along with me today and learning. Hey Wayne, sorry dude, I'm about to head out. But I appreciate you guys being here for this while we tackled the MIT problem set 2 for the um, so we're taking the MIT 6.0002 course through their open courseware, which is completely free, self-paced course. It's just recorded, and then I'm just taking it just on my own pace here. It's just recorded like an actual MIT course was recorded and just posted. So I'm just going to take it in my own way. So we're doing the back half of this course, the second semester, because the first semester is more learning about Python and how to use it. The second semester is about actually, getting into more algorithms and things like that, more computational thinking, data science related information, which is what I'm trying to kind of dive deeper in and get into machine learning. So once we complete this course, we're going to dive into 100 days of machine learning is my goal to really kind of keep that going. But we've watched up to lecture 6 on stream. We are doing like reaction watchings as we go through this. Um, so we are, I have kind of like a pretty unique channel. I haven't seen a lot of people do this to where we're like watching and learning and watching like collegiate level, education videos and lectures and taking notes and learning and kind of like doing like online college basically. Like it's kind of cool, self-paced online college. So if that's something that you guys are kind of interested in doing and learning and teaching yourself and growing as not only like a human but as a student in your own way, then this is where to be. We've watched up to lecture 6 and we're completing right now problem set 2, fastest way to get around MIT. We've completed problem set 1 already. You guys can go check that out on the channel. But yeah, thank you guys so much for being here. We're going to complete that one tomorrow, and then probably what I'll probably do is complete problem set 2 tomorrow, that last section, and then we'll probably watch the next lecture, lecture 7 on confidence intervals, which is about kind of more getting into statistics and things like that with the kind of sampling and your simulations and getting into error and stuff like that. So thank you guys so much for joining me tonight. I really appreciate everybody being here. We went up by like almost 20 subscribers this stream, so super awesome stream. We got a lot of new people in here. So hugs and kisses XOXO to you guys. Cringe. What can I say? But I appreciate you guys being here. Truly, you guys are awesome. Thank you guys so much for supporting me, and I'll support you. Join the Discord, and I'll see you guys tomorrow, like usual. Bye, guys. Have a good day, or good evening, or day, wherever you are.